for this?
All right, y'all ready for this? We're on SAT test number 8, section 3. This is part 2 of section 3. We're doing 11 through 20 now in this video. So in this video we have number 11, and instead of asking you to graph the equation, they give you the graph and they ask for the equation that pertains to this graph. So if we look at the graph, we notice that on both ends it's going up to positive infinity. So this is like a parabola open up. This is actually a 4th degree. It's an even degree polynomial. So this is a 4th degree polynomial because you have 1 0 here and you have 1 here, and right here where it goes up to 0 and then back down to 0 you have a double root. So there's going to be 2 here, 1 here, and 1 there, so there's a total of 4. So our answer should have x to the 4th. The answer A, you have x times x times x. You're going to have an x cubed, so it cannot be answer A. Answer C is also a cubic equation, x times x times x. So that's going to be out. So the answer is either B or D. Well, let's look at the zeros. We have a 0 at x equals to 2. And of course that means that x minus 2 is a factor. We also have a 0 at x equals to negative 3. And if we add 3 to both sides, we get that x plus 3 is a factor. So let's look at the answer choices. X minus 2 and x plus 3. X minus 2 and x plus 3. So the correct answer for number 11 is B. Okay, problem number 12, we have if 2a over b is equal to 1/2, what is the value of b over a? So we're trying to find the value of b over a. Well, we could find a over b by dividing both sides by 2. And divide this by 2, which means you multiply by 1/2. So these will cancel out. So I now know that a over b is equal to 1/2 times 1/2, which is 1/4. Now the easiest way of solving for this, instead of doing cross product and all that, what I recommend is to use the law of reciprocals. Are you familiar with the law of reciprocals? If I take the reciprocal on the left hand side to get b over a, I have to take the reciprocal on the right hand side. So b over a is actually just 4. So the answer here would be D. So the answer is D for problem number 12. Okay, problem number 13. Oil and gas production in a certain area dropped from 4 million barrels in 2000 to 1.9 million barrels in 2013. So it's decreasing. Assuming that the oil and gas production decreased at a constant rate means we have a linear model. Which of the following linear functions F best models the production of barrels in millions of barrels T years after the year 2000? Okay, so if we have a decrease, so the slope here would be negative, and so I'm looking for a negative slope. So it could be this one here, it could be this one here, but I'm pretty sure it's not going to be this one, and it's not going to be this one. Those have positive slope. So what I'm going to do is I'm going to just show you what the graph might look like, and then we can find the slope. So it starts at time 0, starting at in the year 2000, goes out to the year 2013. This is the time, and this would be f of t here. And at the year 2000 we have 4 million, and then over here you're going to have 1.9 million. So starting right here, you've got at the year 2000 you've got 4 million, in the year 2013 you've got 1.9. So you see that it's decreasing steadily. So what we're going to do is find the slope then. Right here, this difference here is 13. So this is 13, and this is what? This is going to be 4 minus 1.9. This is 2.1. So the slope that we're interested in here is rise over run. So it's going to be 2.1 is the rise, and the run is 13, and we already declared that it's negative because it's decreasing. Now, if you look at the answer choices, there's no 2.1 over 13. However, if I multiply this by 10, I can multiply this by 10 to get rid of the decimals, so I'm going to have 21 over 130. And of course, we said that was negative. Negative 21 over 130, that's the right slope that we're looking for. They all have a y-intercept at 4. So the correct answer was C. The correct slope was negative 21 over 130. That's for problem number 13. Okay, moving on to problem number 14. You have a quadratic equation and a linear equation. How many solutions are there to the system equations above? Okay, so this one here, if we solve for y, we're going to have that y is equal to 5x minus 8. And this is also y over here. So that means that I could take this equation right here and set it equal to this equation, since they're both y's. So I'm going to have x squared plus 3x minus 7 is equal to 5x minus 8. And so what we need to do is set this in standard form, set it equal to 0. So I'm going to subtract 5x on both sides. And also I should go ahead and add 8 to both sides. So that way we can set it equal to 0. These will cancel out. And you get 0 on the right hand side. And we now have x squared. 3x minus 5x is a minus 2x. And then 8 minus 7 is plus 1. And this looks like a perfect square trinomial, which is x minus 1 times x minus 1. And so what we have is a double root, but regardless, x equals to 1 is exactly one solution here. So the answer for this one is C. There's exactly one solution for this problem. Okay, problem number 15. We have two functions, g and h, are defined above. So g of x is given as 2x minus 1. H of x is given as 1 minus g of x. What is the value of h of 0? So in order to solve for h of 0, I need to get everything in terms of h of x. And since I have g of x here, and this is also g of x, I can replace this g of x with 2x minus 1. So I'm going to write that here. I'm going to have h of x is equal to 1 minus the value of g of x, which was 2x minus 1. Now right in here, I have to distribute this minus 1 here and here. So that means that what I really have is I have 1 minus 2x, and minus a minus 1 is a plus 1. And so what we want, that's h of x, what do we want? We want h of 0. That means for every x, replace it with a 0. So you're going to have 1 minus 2 times 0, that's 0, plus 1. 1 plus 1 is 2. The key in this problem is to be able to do the right substitution, which what I did up here. So this is the key right here. So the substitution is very important. They're able to do the substitution from the beginning. And when you do that, it just makes it a simple problem. We get rid of g of x by that substitution, have everything in terms of x, and then replace x with 0, and then it's as simple as adding 1 plus 1. So the answer was 2 for number 15. Okay, problem number 16 is a quadratic equation. X squared plus x minus 12 is equal to 0. And A is a solution for this equation. There's probably two solutions. We want one. A is a positive solution. And on these gridded answers, the answers can only be positive. You cannot have a negative answer. So what is the value of A? So in this problem, we're just looking for the positive solution. So maybe we could factor this out and see if we can do a little factoring here. X squared would be x times x. And factors of 12, well, since that's a negative 12, I need a plus here and I need a minus there. and factors of 12 where their difference is going to be 1, I could have 4 minus 3. Would that work? Yeah. You're going to have 4x here and a minus 3x there. That gives you the plus x. So x plus 4 equals to 0, but this will give me a negative answer, and that's not the correct answer. So the other one, x minus 3 is equal to 0. This gives me that x is equal to 3, and this is the correct answer. So on the grid ends, just write 3, and that's the correct answer for number 16. Okay, problem number 17. The sum of negative 2x squared plus x plus 31 and 3x squared plus 7x minus 8 can be written in the form of ax squared plus bx plus c, where a, b, and c are the coefficients. They are constants. So what we want is the sum of the coefficients, the sum of those constants, a, b, and c. Well, one way that we could do this is we could just write 3x squared plus 7x minus 8, and then you would add a minus 2x squared plus x, I'm going to write 1x, and then plus 31. And when we add these together, you're going to have 3 minus 2, you're going to have 1x squared. So this is 1x squared. 7 plus 1 is 8, so you have 8x. And then you have 31 minus 8, that's 23. And then if you add a, b, and c, you're going to have 1 plus 8, which is 9, plus 23, which is 32. So the answer here is 32. Now, is there maybe an easier way of doing this? Is there a quicker way? Well, since you're just adding the coefficients, just take the without having to do all of this right here, there might be an easier, since this is a time test, it might be a quicker way of doing this. What I would do is I would add negative 2 plus 1 plus 31 plus 3 plus 7 and the minus 8. And if you add those together, negative 2 plus 1 is negative 1, plus 31, that gives you 30 here. And then you're going to have 3 plus 7 is 10, 10 minus 8 is 2, and then 30 plus 2 gives you 32. And this would be maybe a quicker or maybe a little bit easier than rewriting everything down and then trying to add all these column by column and then add 1 plus 8 plus 23 to get that answer. Either way, you get the same thing. Now, I'm just showing you some tips, maybe some strategies that will help you work this a little quicker. If you like these tips, if you like these strategies, let me know on the comments. Just write some comments. Give me a thumbs up on this video. We need some more likes for this video. Problem number 18. And here we have a system of equations. Negative x plus y equals to negative 3x, negative 3.5, and x plus 3y equals 9.5. It says if xy satisfies the system of equations above, what is the value of y? So we're looking for y. And I'm looking at something here, and is this a trick question? Is the College Board trying to trick us here? Whoa. Look at this. Minus x plus x, boom, boom, cancel. So now I have 4y is equal to 9 minus 3 is 6. The 0.5's canceled out. So 4y is equal to 6. Divide by 4. I'll tell you how you're going to get tricked here, if anybody got tricked on this. You have to write this as 3 over 2. Improper fraction would be okay. You could write it as 1.5. That would be okay. If you write it as 1.5, that would be very wrong. So do not do mixed numbers. And that might be where they're trying to trick people on this. 1.5 will be read as 11 over 2 because this is the grid end. So you cannot write 11 over 1.5. So this would be junk. Just forget it. 1.5 is okay. Improper fraction is okay. So either 1.5 or 3/2. That's correct. Problem number 19. A startup company opens with 8 employees. So this is in the very beginning when time equals 0. we're going to start with 8 employees. The company's growth plan assumes that 2 new employees are hired each quarter. That's every 3 months. And so 2 times 4, that's 8 employees per year for the first 5 years. If an equation is written in this form, a linear equation, ax plus b, to represent the number of employees, y, employed by the company x quarters after the company is open, what is the value of b? Is this a trick question again? What is the value of b? What they're asking for is what is the y-intercept? Well, at time 0, when x is 0, you're starting off with 8 employees, so b has to be 8. So you start off with 8, the y-intercept is 8. That's all there is to this problem. All this other information here is not necessary. That's it for number 19. Okay, so we're on problem number 20, which is the last one. And we have a circle, and it's indicated here that figure is not drawn to scale. And in the circle above, point A is the center, which is right here. And that means that this angle is the central angle. And the arc, BC, is 2/5. 2/5, by the way, is 40%, so it's 40% of the circumference. If it was 1/2, then this would be 180. So it's going to be a little less than 180. So the whole thing is 360. So 40% is 0.4 times 360. And if we multiply this out, it would be 4 times 36. 4 times 36 is 144. So it's 144 degrees. And you don't have to write the degrees, so just all you do is write 144. And that would be the answer for number 20, which is our last one. So that's the last one. Yay! Now just remember that if you haven't subscribed, make sure you subscribe to this channel, and make sure you hit the like button and hit the bell for notifications, and we'll make some more videos like this. Thank you very much.